Hello, everybody. This is just a quick sound check. We'll be starting the webinar in about 2 minutes' time. Thank you. Good morning, good afternoon, and good evening, and welcome to this Atempo HPC webinar. My name is Nick Crisp from head office in Paris in France, and delighted to welcome you all to this particular session where we'll be taking a closer look at managing petabyte, exabyte scale unstructured data sets, synonymous with, but perhaps no longer exclusive to, HPC environments. And today I'm delighted to be joined by Mike Oakes, who's our senior pre-sales engineer based in the US. Mike will be taking us on a journey through the challenges, requirements, and solutions for large HPC data sets. Good morning, Mike.
Hey, good morning. Good afternoon, Nick.
Okay, great to have you with us today. Mike's going to be talking, his presentation will last around about 20-25 minutes. And then, of course, we'll have time for a few questions, as always, at the end. And if you do have any questions, please do use the questions tab that you'll find at the bottom right-hand part of the webinar interface. So I think that's it from me. I'll hand over straight away to Mike to pick up the prez. Over to you, Mike. Thanks very much.
Thanks, Nick. So real quickly, as Nick mentioned, my name is Mike Oakes. I'm a senior solutions architect, senior sales engineer with Atempo. I'm going to apologize real quick. My allergies are bad today, so if I stop for a second and I suddenly disappear, you didn't lose me. I just had to stop to have a quick coughing fit. So that being said, what are we talking about today at a high level? So the quest for high performance computing, and more precisely, we're talking about, managing those data sets on your high performance computer assets. Maybe it's your production file system, moving things down, protection, backup, something along those lines. And we'll do this at a high level. If you guys have questions, as Nick said, drop them in the chat. We'll get to them at the end. So that being said, what are we talking about? What do we hear a lot of time when we talk to our customers? And we really hear it from two groups. There's the IT resources administrators, those are taking care of the infrastructure, and the researchers. Now, what we hear a lot from the administrators here at the top, you'll see is, a global view of the data landscape, the data ecosystem. How do I understand what's everywhere? What am I managing? Where does it reside? How old is it? Whatever it happens to be. Is it hot? Is it not? Has it not been accessed in 2 years? Why is it sitting on production? The other thing is help offload their workflow, right? So empower the researchers themselves to do more of the, whether it be a restore or, a backup or an archive, within some constraints, of course, right? We don't want to give them free rein. Now, That also comes into how do you automate or enforce some predefined IT rules? Talking about, as I mentioned, to what's hot, right? So, or what's not. If something's on my production file system, and maybe I want to set a rule that it's been there for, if it's older than creation date of, well, let's use an example, 6 months, and it hasn't been touched or modified in 3 weeks, why is it sitting here? Let's get it off. Let's archive it, back it up, move it, do something with it. And there's others that you can set for defining these rules and automating them to make the life easier for the IT administrative staff. Now, from the researcher's perspective, we see a lot of times it's kind of the same set, just from a different angle, right? It's how do I find and locate my data, well, no matter where it is, right? So is there a global index or a searchable index or something that I can go put some information into, or maybe I did some metadata tag, I want to search on that. How can I find it quickly and easily so I'm not searching forever looking for my data, right? And of course, more autonomy, less dependency on IT. It's the old, chicken and the egg thing. What comes first? Who wants to do what? But allowing them to do maybe just self-restores from a global archive or a global backup, like giving them just the ability to retrieve. So that doesn't have to be done by the IT staff. Or moving data between two locations, as long as they're given permissions to do read or write or access those to particular devices. And of course, move data securely. I just mentioned that, moving things between locations, having hashes in play to ensure data movement was correct, or maybe on an archive or maybe on a backup. Making sure the hashes are also on a recall, it's checked to ensure that data validity when that data is recalled. So these are some of the quick high level things we usually see 9 times out of 10 when we talk to some of these environments. So use cases real quick for each one of those, or we'll do like 3 use cases here. The first one we already talked about, like that self-moving, right? The mobility, but also archiving and backup. In this case, this happened to be one of our customers, which is a research center for genomics. And they needed the ability to basically, you see their high performance computing infrastructure in the middle there, but they need the ability to 1, preserve and protect their data, but 2, move it between different locations if need be, or auto archive and hot tier it after 2 weeks. Now, this happened to be their IT rule. If it's been on there for 2 weeks and it hasn't been touched, get it off my production. Now, with the Miria solution, you see data movers in the middle here. The data movers are the ones that do all the work. The Miria server itself, think of it as a traffic cop. It's the control point, all access, web interfacing, everything through it. These data movers here in this particular example allowed the researchers to move their own data because they were given, maybe it's done by group or by a particular user, to move data from the HPC platform. Maybe it's out of the hot storage into home or into cold tape archive, but also the ability to recall it if they need to bring something back and put it on maybe home and not HPC, right? Or the hot storage, but also keeping multiple copies. So I always tell people if the data is that important, 1 copy is never enough, usually, because if you lose that 1 copy and your original goes bad or something's happened to it, bit rot happens and other things, you've lost all that work. So keeping 2 copies sometimes is very important in these environments. Now, we have the ability, Atempo and with Miria has the ability, when you have 2 copies, is you can send independent hashes with every file that gets stored, whether it's tape, cloud, disk, doesn't matter, or file system. Now, in the event of a recall, we'll check the hash on a recall. And for some reason, if something's bad on, we'll say, storage manager container 1, which has been bit rot or something got corrupted, we can automatically go and turn around and pull it from storage manager container 2, feed it to the user or the application. They can continue on with their workflow, right? So unimpeded production, unimpeded HPC performance. So, sorry, I apologize again about the allergies there. So the key thing here, right? Self-archive, self-backup, self-movement, right? But still having global control. You could actually do it in the reverse here and say, I have global archive policies happening and just allowing them to self-retrieve. You get very granular on how you set these up to meet the workflow requirements of the environment you're in. Another quick example here is someone that actually, strictly from the mobility phase. This happened to be an HPC facility, university out of Asia. And this was, they needed a mobility. Now, they wanted to be able to write their own front-end interface. They liked our interface, but they wanted to restrict their users to do certain things and certain things only. Now, with the REST interface that we have that comes with the product, you can program straight to it. Full REST API integration. Anything I can do with the GUI, or we can do with our GUI, you can program too. In this case, they had a pretty big system, right? It was it was a Lustre environment, but they were also using Object Store S3 as well as NAS Ocean Store. And they had, notice this one, this is about 80 petabytes, and they needed the ability to move things or allow users to, or certain groups to, move things off of production, maybe into object storage, or pull it back to the NAS after they've done their production run. They run their modeling sequence to say, let me pull it back to the NAS. I'll do my analysis now and look at my data there, not impact the production, free up that space on their production storage. And again, they did that all, they programmed their interface. It's called MIY or My Web Portal using our REST API. Now, the classic example here I'm going to give real quickly, this is not just a backup. It says backup at scale. There is the notion here that people, environments, HPC and others, limited footprint, limited storage sometimes comes into play. So I can do a backup, but I also want to have DR. So I want the ability to have both in a single platform. Now, the Miria or Atempo tool enables you to do that. You can have a backup and a DR all together. In this case, in this example, you see a GPFS system and an Isilon system up above. And this could be Lustre, right, or another type of file system. What this allows us to do, we can do full backups, and with GPFS, Isilon, Lustre, because we built our own FastScan for Lustre server, you don't have to walk the file system after first seed of data for a backup. We'll take incrementals. In the case of the Lustre server, of course, we're using the kernel change logs to go pull out the information that's changed since the last run, and we store that in the database. Now, why is this important? Customer is running fine on the GPFS system here. They're doing their backup. First time they do a backup, we seed this scaler, GPFS scaler on the other side. Now, we can snapshot GPFS. Next time you run a backup, or we run a backup, I should say, we're going to go ahead and take the incrementals off of the GPFS system or the Isilon system. And right before we apply it to that other side, we'll do a snapshot over there. And then we'll apply the changes. Why? Now we have versioning. Now, in this case, typical backup and archive, we would store all information, ACLs, permissions, XAdders, whatever it happens to be, in the database to replay in line when it comes off of tape, a disk, or something else. But to use this as basically a backup and a DR, I need to also put those on that file system. So we'll do that. And now we have our versioning for backup. And in the event of one of these fail, maybe it's the GPFS system, users can still access their data through the GPFS protocol nodes. Now it's going to be slower. It's not full, it's not scaled for full production, or you could if you wanted to, but you don't lose access. You still can work on the data. You can still do your modeling. You can still do your analysis. And it's also a basic, as we said, it's also a backup. So you can scroll through time with those snapshots, and you do it on us. It's in our database to pick up files or directories you need to pull back if you want it. Now, once this is finished, and maybe you've healed the GPFS system, maybe it was a networking issue, maybe switch went down, something. All the changes that happen, you can turn around, sync back the other way. Straight off this GPFS 10 petabyte scaler on the target side, scale it all back, or sync it all back to the production side. Go ahead and switch your users, bring it back online. Now, as I mentioned, all ACLs, all versioning, all storage through our Snap Store, all accessible to give you those uptimes you may need, depending on your environment. Is it fit every environment? No. Some environments require this type of availability. So how do we do all that? Right. So what are the tools and we're a software tool, if I didn't mention that up front. So all software you can run on your hardware. It's Windows, Linux, and mostly in the HPC environment, we're going to see Linux. But what are these tools underneath the hood? What is the Miria product line itself? And it really comes down, there's 5 pillars. As you see at the bottom, you'll see backup and archive at the 7 o'clock and 5 o'clock position. Data protection, data preservation. These are the tried and true, we'll call them battle tests. So we've been doing this now for almost 30 years. We know how to do archive and backup and data movement. What we did about 7-8 years ago, we took a hard look at the unstructured data market. And what we saw coming in, what we call the data tsunami, the explosion of the amount of data being both consumed and created. And we took a look at, hey, you know what? People are going to need to get off older pieces of storage. And this is going more to the 3 o'clock position here, the migration. something older, antiquated. I need to get my data from point A to point B, and I need to shut down point A. Now, think of this as time-based. If you only need to do that, you don't need to buy the software to perpetuity. I just need to basically rent the software. I need to get off my old production to my new production, shut my old production down, maybe turn it into scratch. But I don't need to keep the software running into perpetuity. Right? So maybe 6 months, whatever it happens to be in a capacity. Now, to the left of that is mobility. Think of this more the copy, sync, and move, or we could think of, we call it easy move, right? Movement of data between two portals, or the thing you saw the MIY before from the Asian facility. Moving data, keeping things in sync. Right? Excuse me. It does a little bit different things in migration, but underneath the hood, same data movement engine. And that goes the same for backup and archive. Backup is data protection, right? You're keeping all versioning, right? You set your schedules and so forth. Archive, typically more long-term, right? Your data preservation. Maybe you do it once a quarter, once every 6 months, you run an archive. Choice is yours. But they do different things, and you can set different options, especially within the archive, because you can also say, as we mentioned earlier, after so much time, or not so much time, how old the file is, last time it's been accessed, last time it's been modified, you can gang these together to either do the archive or move data off production, right, to something else. They do a little different up on the surface, but the same data movement engine under the hood. And the reason why I'm bringing this up, it goes back to that at the beginning I was talking about understanding that data landscape or understanding that data in the environment, right? Analytics is now coming within the product. Right now, the version that's out, it's a standalone product that's external from Miria. We're rolling it in with data movement coming in November. Now, when we do this, right, you can basically glean all information about anything you're working on or that falls within one of these other 4 pillars: mobility, migration, archive, and backup. And as long as you have a valid license for any one of those, right, analytics comes for free, no extra cost. The other thing with it is also, maybe I'm only doing 2 petabytes under management of Miria, but I got 15 petabytes external. You can glean information about that as well. No extra cost. Now, it may be something that's attached to a data mover, or it could be something that we're not talking to. There's offline crawlers. There's one for Linux and there's one for Windows. You can run it on that particular file system, gather all that information, bring it back, import it right into this analytics tool here, and now get complete information about that external system as well. The only time you have to worry about any type of licensing model is if you're going to act upon that external data. You just need to make sure your capacity license that you have, maybe for backup or archive or something that you want to act upon, is currently you have a valid license for that capacity within Miria. If not, you just need to up it a little. But to use the tool, no extra cost. Those are the 5 software pillars. And as I said earlier, you can run on your hardware. We have sizing guides. Typical data movers are not big. I mean, on average, it's 1 U box, 2 CPUs, data mover, 16 to 32 gigs of memory, maybe 16 to 20 cores, depending on the workload. Could be as small as 10 to 12 per CPU. It all depends on the workload being done. One thing I will mention, because people ask, can I use virtual machines? And you can, depending on the workflow. You can't if you're going to tape. The SCSI layer that talks to tape drives for the virtual machines is very, shall we say, unreliable, and it will drop connections going to the tape drive. Anything talking to tape, and I say libraries, I should say, has to be physical movers or base metal movers. So real quickly, from the analytics perspective, if you think about being able to crawl all the resources, and one quick thing I want to mention, none of this information, when gathered from analytics, comes back to Atempo. This is your information. You don't need to be giving it to us, and we don't want to know about it. Now, that being said, you'll notice here it talks about public clouds and private clouds. S3, AWS, is the first one to roll in. That'll be coming in version 2. Version 1 is out right now. And then right after that, we'll start rolling in all the other clouds, the Swifts, GCP, if you choose to use those. A lot of people don't outside of HPC. or inside of HPC, sorry. But you can use those as well to start gathering information about. You can write to them now. They can be targets. They can be sources under Miria. This is strictly from the analytics package perspective. But it gives you a complete view across your entire data sets, across all of your infrastructure. And that's important. It goes back to, how do I manage all of that information? How do I know what's where? How old is it? What's my biggest file? How long has it been there? What's the creation? All of that information needs to be understood to effectively manage it. Now, one thing I'll mention, because somebody's probably going to ask what database we're using, because this can get very, very large. We're actually using the Elasticsearch database. Why? Billions and billions of files in a very quick search. Every file will have a unique fingerprint. This is important because you want to start detecting duplicates, right? When we calculate the fingerprint on the file, and we use a couple different algorithms, it's not just a hash. When two of them are the same, we know that's a duplicate, because no two files should ever have the same fingerprint unless they exactly match. This goes back to looking at duplicates. It also is going to add more metadata in later for things like multi-tenancy and so forth. And that's going to get into adding more things into the fingerprint. Sorry. But as you see here, multiple sites, multiple clouds. Basically, when we have it all together for you, it's unfettered access to understand the environment of the ecosystem. Now, what do we talk to? This right now. This is kind of a small subset, but if you think about it, any scale out NAS, any scale out file system from the Miria perspective, right? Cloud, tape, object storage. One thing I'll mention from a tape and optical disk, as it was same thing with, we don't need to know about your data from an analytics perspective. We also, it's your data. We don't wrap data. We don't put it in some type of format where you get maybe it's going to cloud and you get an object ID back, but you don't know the name unless you have the appliance that has the map in it. That's not our philosophy. So when things go to tape, it's basically the archive exchange format, basically PAX tar, which means even if we're not in line, you can untar the tape, or LTFS. When you go to cloud or you're writing to another piece of storage, file looks like there's two modes you can do it in: containerize, which is a tar or a zip, or you can do what we call one-to-one, which is kind of what SnapStore does, because it looks just like on source and target. They look exactly the same. So, and if you go to cloud or something else, even another, like I said, another piece of storage, you see the exact structure, the exact name, everything as it existed on source. So you can go recall it. You could give people read access. They can go pull things down, like the S3 with the S3 browser. That's important. Your data, right? We have no business, stopping you from accessing your data, putting a wrapper around it. Now, real quickly, last thing about the analytics package. And I don't want to stress this because I said version 1 and version 2. So version 1, there's 4 distinct, basically, phases or things you'll go through when you're doing an analytics workflow, right? The first thing, of course, is I need to discover my data. The second thing is you want to analyze it. So version 1 is discover and analyze phase. It's external. Now, what do you do once you get that information? You've analyzed it. Now you need to start making some decisions upon it and then act upon those decisions. So that's in version 2 coming out, like I said, in November, the decision and act, because now within the analytics tool, when it's wrapped into Miria, I can click on things and I can set up my own search patterns. And I want to look for things that are 2 years old and of a certain size and certain file type. Hey, all of those I found, I want to archive them, or I want to back them up, or I don't want to move them from storage A to storage B. So you can start to do that manually. Now, what'll come in 2023 is you can start to automate these, set up your own key business metrics to say, I want certain files of so many at certain location. There's a lot of ways you can put this together, but that puts all 4 phases together, right? That gets you the basically discover, the analyze, the decide, and the act, all within the product. And what also is our data scientists have done is they've been working on code, and this code is basically to understand file system patterns. So, and it's more to and when I say understand, again, stays on site. We have nothing to do with it once it's at your site. It's basically detecting abnormalities, right? You can think about crypto lockers. You can think about, viruses or some other non-normal pattern happening that you want to get alerted upon. Maybe you're expecting a data dump at 8 o'clock at night, and it comes every Tuesday. If you get it, you don't care. If you don't get it, you'd like to be alerted. So it learns about all this stuff. That's coming in, like I said, version 2.1 coming in 2023. So I kind of did this in reverse real quick. We're just about done. Who's Atempo? So as I mentioned, we've been around almost 30 years now, right? We are a data preservation, data protection company. That's how we got our start. Now, of course, with the advent of the massive amounts of unstructured data, we've got into data management, right? More data movement, more refined data movement. It allows you, as it says on the screen here, right? Protect, store, move, retrieve, but manage those assets regardless of where they reside, and giving access to at a level of a user or a group or something along those lines, particular pieces of storage. And just like you can do this in Miria, where I may say a user or a group has particular accesses to only certain pieces of storage, analytics is going to work the same way. So you can do localized users to localized storage, or you can do global across resources, and you can set up different dashboards and different metrics and users can do it themselves and have multiple dashboards for different things they want to look at or maybe monitoring over certain times and on certain storages. So it mentions here 27 years, I said about 30, well north of 2,000 customers, and we're about 265 or 56, one or the other, employees in the company right now. Lastly, people ask, what's the key benefits? Why Atempo, right? All-in-one Atempo management platform you'll see here. But we just talked about the analytics, right? Understanding the data ecosystem, understanding the environment only enhances your ability to manage it. Moving data between resources, offloading our hot storage or our production storage for things that don't need to be there, whether it be manual or automatic, right? And that automation, right, is removing or reducing those costs, allows IT staff to focus on other things and being data wranglers and pulling data off tape or some other place and putting it in for a user. Let the users do that, right? Let them go grab their own data. Full interoperability. So what we're talking about here is a GPFS doesn't natively talk to an Isilon, which doesn't natively talk to a Cumulative, which doesn't natively talk to the cloud, we'll say. We can enable that. We enable those heterogeneous architectures. So you can use the best of breed or whatever's in your environment and have those interconnected to meet the workflow without having to go write your own tools and write your own scripts. You can if you want and put it through us if you want. If you want to make your life easier, just have us do it. And it is a multi-service platform. Just because a data mover is doing archive doesn't mean it can't do backup, can't do migration, can't do some type of movement for mobility, or gather analytics if it's been also designated as an analytics agent. So you can reduce the footprint by having things all in a couple of servers, or depending on the workload, and usually size data movers to meet the workload, but reducing the cost for managing my data across my organization. With that, I'm going to turn it back over to Nick, and thanks everyone for your time.
Thanks a lot, Mike. Great presentation as ever, and sounds like the allergies were letting you speak clearly for the best part of 25 minutes there. So well done with that. Yeah. So I have a few questions for you. You might want to take a quick look at the questions tab. Also, if you do have any questions, please do ask, and we'll get back to you either orally or by email in a very, very short future. There will be the replay of this webinar as well that will go out on an email sometime tomorrow. And just a final thing, there is a poll as well. If you want to click on the poll tab on the webinar interface, we just have one or two quick questions. You might like to just take 30 seconds to give us some feedback. That would be great. So I have a couple of questions, Mike, if I can. And yeah, sure. The first one is, okay, how does Miria assure data integrity on long or even short-term asset storage?
I think I mentioned that earlier on, but we have the ability to do hashes. Now you can choose those hashes. They could be MD5, SHA-256, XX hash, whatever. But that's stored within the database. And oh, by the way, if it's going to tape, we can store it on the tape. And why this becomes important is you can have the tape both exercise and check the hash, because we can fire a command off to a tape library in a particular tape and say, I want to go exercise this tape and check the hash. Basically do a storage manager container check. And it will read the hash or the checksum, and then compute it against the data that's right behind it, and it walks the tape because it goes hash file, right? So you're not going along and shoe shining the tape. But that ensures when you bring it back the day you stored it, if the hashes match, when we recall and recompute it, ensures the viability of the data you've stored is correct.
Okay, great. Thank you very much. A question on analytics and how can I use it to gather information about assets other than those currently in a Miria workflow? I guess, in other words, the analytics parts of Miria can look at other data storages, or is that not the case?
You can. So if we have no connection to it, right? No network connection, whatever it happens to be, you can use those offline crawlers. There's one for Windows and one for Linux, and you basically load it on some system that has access to that file system. It runs, it scans, it gives you a packetized and zipped up tar gzip file that you then take back to the Miria server, or the analytics server, and there's an import job. You just say, I want to import this file. You tell it the location. It'll take all that information and ingest it into the Elasticsearch database. And then from there, you can search it. You can do finds. You can set up different criteria searches, all from a storage that wasn't attached to the server.
Okay. Thank you very much. Question on archiving. For term archiving, does Miria offer some type of deduplication?
I'm sorry, you broke up for a second on my side, Nick.
It's about term archiving. Does Miria offer some type of deduplication?
Yes. So it's file level deduplication. It's not block level because we work at the file level. And what it does is you can tell it. We'll use the example of an archive. When I go to archive a file, compute the hash. Right. And when I compute the hash, next time I go to do an archive, the hash gets computed again. Right. Now, if file in a different location has the same exact hash, basically, as the one we've already stored, it's the same file. So we're not going to store it again. We'll have a pointer to it because maybe it was in /Mike and maybe it's in /Nick. It's the same file, Mike1. And you know, there's no sense of naming it. Maybe it's called Mike2, depending on how the hash works. But you don't need to store it again. So you can deduplicate within a particular archive. And you can also group together storage manager containers, which there are different locations. And you put them in what we call a deduplication domain. So if a hash matches in one of these different storage manager containers to one that's trying to go up, we already know it's a duplicate. We'll just put a pointer to that other location. And when you go to recall it, wherever you want to recall it to, you just say, I want to recall this file on the back end. We go grab it from wherever it is, and we'll put it down to the location you tell us to put it to.
Okay, thank you very much. I have a question on APIs as well. I know you mentioned that in one of the use cases about the university. It's basically saying, how can we leverage APIs, REST APIs with Miria? Maybe just go back over that.
Yeah, so anything we can do within the new web GUI, and for all of you that may remember earlier on the ADA product, there was an administrative Windows GUI. I call it very comprehensive. Some people call it very convoluted. We rewrote the GUI starting in the Miria release 3.14, and it's now all HTTP, HTTPS. It'll come to full fruition the end of this year in the December release. Right now, migration, easy move, backup is all in it. What's coming in the November release will be the analytics. What's coming in the June release will start to roll in the user archive. Once all of those are in, and I know I'm going a long way to get to the API, we're going to deprecate that older GUI. Now, why? We wrote the GUI to be fully API REST compliant. So anything that we can do in that GUI, archive, backup, move data, whatever, you can do with our REST API. And you get all the docs with it when you install the product. And you can just basically go to the server and use redoc, and you get all the API REST information will come up.
Okay. Thanks very much, Mike. I see that we've just run over time very slightly, so I think we can wrap up the session. I'd like to thank Armel as well, who's been answering some of the questions on the questions tab. We'll leave the session open just for a few more minutes if you do have any more questions. If you'd like to answer the poll, then that would be great. So a big thanks to everybody for listening. A big thanks to you, Mike, for taking the presentation and making it so interesting, and I hope useful to everyone.
All right, guys.
And look forward to seeing you soon. You may have seen Mike. Obviously, a lot of you already know Mike. He was at NAB very recently. At the end of this year, we'll be at Supercomputing over in Dallas. So come and see us there. And you have Mike's email address if you'd like to contact him for any information. Happy to help, I'm sure. So big thanks to everyone, and have a great day, and speak to you all soon. Take care. Bye, Mike.
Thanks, everyone. Bye-bye. Have a great day.